Okay, in this lab last class, we were trying to investigate the properties of metals, nonmetals, and metalloids. Now, looking back at the periodic table again, I think we could start off by drawing our little staircase. And then we identify boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and acetine as our metalloids. Everything to the left of that would be our metals, and then everything to the right of that would be our nonmetals. So in this lab, we were investigating with 8 different elements. So element 6, so we have some carbon there, and we can look back at our periodic table and say, oh, carbon is a nonmetal. Remember, our goal isn't to determine what are the metals or nonmetals, it's to determine their properties. Element 12 is, so in this lab we had carbon, we have 12, which is magnesium. Now we know based on its location that magnesium is a metal. Element 13 is aluminum, that's another metal. Element 14 over here, that's silicone, so that's our metalloid we're going to be using in this lab. So 14 is silicone. Element 16, moving across the periodic table, we have some sulfur. Sulfur is just a nonmetal. Element 26, 29, and 30 are then 3 transition metals on the periodic table. So we have iron, copper, and zinc. I'm sorry, iron, we'll just say iron, copper, and zinc. I think in the lab we actually use tin, but we'll just say it's copper for now. And then element 30 is zinc. So now what we want to do is to try and determine some of the properties of these elements. So I'm going to start out by just looking at their appearance and what they look like. We are then going to try and crush them to see if they are malleable or brittle. Now, if you tap a metal with a hammer, or you tap something with a hammer and it flattens out, or if it's bendable, we call that malleable. And the opposite of that, if we tapped it with a hammer and this element was crushed into a powder, we'd say that's more brittle. We're then going to look at the conductivity of these elements. So we'll hook them up to a conductivity tester and see if we can have a current flow through them. We are then going to react them with hydrochloric acid. So we'll see what these elements do when they react with an acid. And then we'll try and react them with a copper chloride solution to see if anything happens here. So let's run through these elements now. So we look at carbon, and I would say it is not shiny. You know, it's kind of a darker black color. It looks almost like charcoal. That's really what charcoal is. So I then tap the carbon sample, and it is brittle. It breaks apart. I then hook the conductivity meter up to the carbon, and we get no current flowing through it this time. I put some drops of the HCl on the carbon, and nothing happens. So let's write nothing. I then put a drop of copper chloride on my carbon, and again, nothing happens. Okay, what about the magnesium now? The magnesium is this shiny little strip. And although parts of it might look rusty almost, when I kind of scrape that off, it does look shiny underneath. Now the magnesium, I'm able to take my little strip and just kind of bend it freely back and forth. So I would say it is malleable. Conductivity, I hook my conductivity tester up to it, and yes, it does kind of cause this little light to flicker on the conductivity tester. So it must be allowing a current to flow through it. I put some drops of HCl on my magnesium, and I start seeing these little fizzing and bubbles forming. So I do see it react with the hydrochloric acid. I put the copper chloride on my magnesium, and I put a drop on this, and my little strip starts changing color. So again, I noticed some little change here. So it looks like the magnesium was shiny, malleable, conducts electricity, did react with HCl, and did react with CuCl2. Appearance. Now my aluminum, kind of like aluminum foil, does look shiny. I was able to bend that back and forth. When I hooked the conductivity tester up to it, it did conduct electricity. The little light kind of flickered there. When I put my hydrochloric acid on my aluminum, this time I couldn't see any observable change. Didn't seem like anything happened. When I put my copper chloride drop on my sample of aluminum, I did see a color change though. So it seemed like I saw a color change at that time. Okay, what about my silicone, my metalloid? This one also looks like this shiny kind of rocky element. When I try and bend it or tap on it, nothing really happens and it kind of just crumbles apart. So this element I would say is brittle. When I hooked my conductivity tester up to it, it did conduct a current and I saw the little light flicker there. When I put my HCl drop on the silicone, nothing happened. And then when I put a little copper chloride drop on the silicone, again, nothing happened. Okay, moving along. What about with my sulfur? The sulfur was like this yellow block. Again, not shiny. Oops. I couldn't really bend it, so I tapped it with a hammer, and again, it just broke apart into this little powder. So I would say that's brittle. I hooked my conductivity tester up to it, and nothing happened. I didn't get any flickering of the light there. So it looks like it's not conducting electricity. I put a drop of HCl on my sample of sulfur, and nothing happened. And then I put a drop of copper chloride on my sulfur, and again, nothing happened. Okay, what about my iron? Now, my iron at first looked all rusted almost. It looks like steel wool, and that's what steel wool really is. It's just a sample of this fine iron threads. But when I kind of scraped it off, I could see this shiny metal underneath. I was able to bend these little fine parts of iron. I was able to bend them pretty freely there. So I would say it's malleable. When I hooked my conductivity tester up to it, yes, the little light started flickering. So it was conducting electricity. Or current, I should say. When I put my drop of HCl on the iron, I did see some bubbles this time, and a little smoke was coming out. So I was getting a little reaction there. And then when I put my copper chloride on there, I again noticed a little color change. Okay, what about copper? Now copper was, looked a little bit more brownish in appearance, but it was still shiny. When I took my little copper strip, I was able to bend it. When I hooked my conductivity tester up to it, it was flickering there. We were seeing a little current passing through it. When I put my HCl on it, I didn't notice something happen this time. And because copper chloride already has copper in it, it might become instinctive later, but we didn't see a reaction with the copper chloride. Okay, for my last element, my last metal here is zinc. Zinc was also the shiny little metal. I was able to bend it again, so it was malleable. When I hooked my conductivity tester up to it, I did see some flickering, so it was conducting a current. When I put the HCl drop on it, I was getting these little bubbles forming. And then when I put the copper chloride drop on it, I again noticed a little color change. Okay, so now using all of this data, you need to try and come up with a general idea about what are the general properties of metals, nonmetals, and metalloids. Remember, things might not always follow a trend, but we're just trying to come up with an overall generalization. Now, for the supplemental part of this lab, I wanted you to try and find out which one of these three metals, potassium, rubidium, or strontium, would be the most reactive with hydrochloric acid. The challenge of this question was I didn't give you any of these three metals to answer the question. I gave you magnesium, calcium, and aluminum. Now notice on the periodic table where these are relative to one another. Magnesium's on the upper left, aluminum's on the upper right, calcium's on the lower left. So what we did in this supplemental portion of the lab is I added these three metals to hydrochloric acid and to water. So when I put the Mg with HCl, with a drop of HCl, I saw little bubbles forming. When I put the aluminum with the HCl, I didn't notice anything happening. And then when I put the calcium with the HCl, I saw bubbles, but these were even bubbling more than the magnesium. What about with just water? When I put a drop of water on the magnesium strip, nothing happened. When I put a drop of water on the aluminum, nothing happened. But when I put a drop of water on my little piece of calcium, I again saw lots of fizzing and bubbles forming. So using this data, try and come up with a generalization about the reactivity of metals. Where are the most reactive metals found? Are they on the top left, the top right, the bottom left, or the bottom right? Once you identify the trend, I think you can then apply it to the question I proposed earlier. So I hope this helps, and let me know if you have any questions.